Hello friends, in this video we'll see the topic bounded sequences of real numbers. Let's see definition of bounded above sequence. A sequence xn of real numbers is said to be bounded above if there exists a real number m such that xn is less equal. Xn means nth term of the sequence xn, so that xn is less equal m for all n belongs to n. Means a sequence of real numbers xn is said to be bounded above if there exists a real number m such that each term of the sequence is less equal that real number m. Next definition, bounded below. A sequence xn of real numbers is said to be bounded below if there exists a real number small m such that xn is greater or equal small m for all n belongs to m. Means if there exists a real number small m such that each term of the sequence xn is greater or equal m, then we have to say that sequence has a bounded below sequence. Bounded sequence. A sequence of real numbers which is both bounded above and bounded below is called a bounded sequence. Means a sequence which is both bounded above and bounded below is called a bounded sequence. Next definition, unbounded sequence. bounded above or not bounded below is called an unbounded sequence. Let's see examples of bounded above, bounded below, and unbounded sequences of real numbers. Let xn is equal to 1 by n for n belongs to n. Here we can observe that xn is greater equal 0 and less equal 1 for all n belongs to n. Therefore, the sequence xn is bounded above as well as bounded below. See, because we have a real number 1 such that each term of the sequence less equal 1, therefore the sequence xn is bounded above, and we have also a real number 0 such that each term of the sequence is greater or equal 0, therefore xn is also bounded below. Therefore the sequence xn having terms 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on is bounded above and bounded below. Hence, it is bounded sequence. Example number 2. Let xn is equal to suppose minus n for n belongs to n. Then the sequence here, sequence xn is sequence whose terms are minus 1, minus 2, minus 3, and minus 4, and so on. See here, you can see that each term of the sequence xn is greater or equal 0 for all n belongs to n, or you can say greater or equal, so each term of the sequence is less than or equal to 0. Each term of the sequence is less equal 0, or you can say less equal minus 1. Means we have a real number 0 such that each term of the sequence is less equal 0. Therefore, sequence is bounded above. But see, we have we don't have any real number such that each term of the sequence is greater or equal that real number. Therefore, xn is not bounded below. Means this is bounded above but not bounded below sequence of real numbers. Next example. Let xn is equal to n square for n belongs to n. Then sequence xn is equal to a sequence whose terms are 1, 4, 9, 16, 25, and so on. Here you can note that each term of the sequence is greater equal 0, or you can say greater equal 1. Therefore, xn is means we have a real number 0, so that each term of the sequence is greater equal 0. Therefore, xn is bounded below. But there is no real number such that each term of the sequence is less equal that real number. Therefore, xn is not bounded above. Means this is bounded below sequence which is not bounded above. Let's see next example. Let xn is equal to minus 1 raised to n plus 1 minus 1 raised to n plus 1 into n for a natural number n belongs to n. Then xn is a sequence whose terms are 1 minus 1 1 minus 1 1 minus 1 and so on. Means 1 minus 1 alternatively. Oh, sorry. Terms of this sequence are not plus minus 1 alternatively, which are first term is 1, second is minus 2, third term is 3, fourth is minus 4, 5, minus 6, and so on. Note that xn is not bounded above and not bounded below. Means you can say that xn is neither bounded above nor bounded below. See, this is not bounded above sequence because we don't have a real number, so that each term of the sequence is less equal that real number, which is not bounded below because we don't have a real number, so that each term of the sequence is greater equal that real number. Therefore, this is neither bounded above nor bounded below sequence of real numbers. Let xn be a constant sequence of real numbers. That means xn is equal to k for all n belongs to n and for some real number k. Means each term of the sequence xn is equal to k for some real number k. That means xn is a sequence whose each term is that k. Means if you take k is equal to 1, the sequence will be 1 1 1 1 and so on. If k is equal to 0, the sequence is 0 0 0 and so on. If k is equal to suppose -3, then each term of the sequence is -3 -3 comma -3 -3 and so on. And so you can note that xn is bounded sequence because it is both bounded above as well as bounded below. Let's see the relation between convergent and bounded sequence of real numbers. This is one theorem. Every convergent sequence of real numbers is bounded. Means if you take any convergent sequence of real numbers, it must be a bounded sequence of real numbers. Let's see its proof. Let xn be any convergent sequence of real numbers. We claim that xn is bounded sequence of real numbers. Means actually you have to prove it is both bounded above and bounded below. Okay. See, we have xn is convergent sequence of real numbers. Therefore, there exists a real number L such that for every epsilon greater than 0, there exists a natural number n such that, or you can say natural number n naught with mod of xn minus L is less than epsilon for all n greater equal n naught. Let's fix epsilon. Take epsilon is equal to 1. It is greater than 0. Then we have mod of xn minus L is less than 1 for all n greater equal n naught. Therefore, we can write minus 1 less equal xn minus L less equal 1, sorry, not less equal, it is strictly, yeah, minus 1 less than xn minus L less than 1 for all n greater equal n naught. Add L throughout, we get L minus 1 less than xn less than L plus 1 for all n greater equal n naught. Take capital M is equal to maximum of L plus 1 x1 x2 up to x suffix x naught minus 1, and small m is equal to minimum of L minus 1 x1 x2 up to x naught minus 1. Then you can observe that small m is less equal xn less equal capital M for all n belongs to the set of natural number n, because for n greater equal n naught, for n greater equal n naught, xn is less than m less than capital M and greater than small m, and we are taking m is equal to maximum of L plus 1 x1 x2 up to x naught minus 1, and small m is equal to minimum of L minus 1 x1 x2 up to x naught minus 1. See, m is equal to maximum of L plus 1 x1 x2 up to x naught plus 1 x n naught minus 1. It means m is greater equal L plus 1 x1 x2 to x naught minus 1. For n greater equal n naught, already for n greater equal n naught, xn will be strictly less than L plus 1, and for n less than n naught, xn will be less equal m. Okay. Similarly, small m, we are taking minimum of L minus 1 x1 x2 x naught minus 1, means small m is less equal L minus 1 x1 x2 up to x naught minus 1. Okay. And you can note that m, small m, capital M are real numbers, therefore xn is bounded above and bounded below sequence of real numbers, and hence xn is bounded sequence. And hence we prove that every convergent sequence of real numbers is bounded. Means if you have any convergent sequence, it is bounded. But its converse is not true. That means every bounded sequence of real numbers may not be convergent. See, every convergent sequence is bounded, but every bounded sequence of real numbers may not be convergent. For example, if we take xn is equal to -1 raised to n plus 1 for n belongs to n, then sequence xn is a sequence whose terms are 1 minus 1 1 minus 1 1 minus 1 alternatively, and you can say that xn is bounded above because each term of the sequence is less equal 1. Means we have a real number 1, so that each term of the sequence is less equal 1, therefore it is bounded above. Similarly, each term of the sequence is greater equal -1, means we have a real number -1, so that each term of the sequence is greater equal -1, therefore it is bounded below also. And hence xn is bounded. But we have seen that xn is not convergent. Okay, I am stopping the video. Thanks for watching it.